Hi everyone. I wanted to go through an example of computing the area common to two polar curves. So here we have the circle, r equals 6 cos theta, and then this limacon, which is r equals 2 plus 2 cos theta. And I want to write an integral expression for the area common to both, so the area that's inside the circle and the limacon. So I'm going to focus on just this top half and then we'll double that. The tricky thing about polar area is understanding how the regions are defined. And so for us, we're going to split this up into two pieces. There's this piece, remembering that in polar, we think about area radiating from the pole. So we'll call this region 1, and then this piece, which is region 2. Right, so this is region 2, and then this is region 1. So the tricky part, as I said, is just understanding the different way that we think of area in polar, area under a curve. So for region 1, we want the area that's between this curve and the pole. This curve is actually the limacon. Now for region 2, that's when the circle becomes the bounding curve. And so at this point right here, we're going to switch from integrating under the limacon to integrating under the circle. And the key here is figuring out where these two things intersect, right? And that's at this ray right here. So this is just some algebra. We're just going to set r equals 2 plus 2 cos theta and r equals 6 cos theta. We're going to set these two things equal to each other. And of course you get that cos theta equals 1/2. So that means that theta is pi over 3 and 5 pi over 3 and so on. For us, obviously we want theta equals pi over 3. So from here to here, we're going to integrate under the limacon, and then from here to here, which is pi over 2, we're going to integrate under the circle, right? So what's that going to look like? It's going to look like this. So the area under the region 1 is going to be the integral from 0 to pi over 3 of the limacon. So that's 2 plus 2 cos theta squared d theta. And of course we want half of that. For 2, the area is going to be the integral from, pi over 3 to pi over 2 of the circle. And the circle has equation 6 cos theta squared d theta. And again, we want half of that. Right? Now, you could find this area by using the area of a segment of a circle, but we might as well just set up the integral. So to find the total area of this region, we would compute this, and then this, add them, and then double it, of course, to get the total area.